Welcome to qnawire.
Okay, so for this problem in the beginning, we have two mass M1 and M2, and we know their mass. Now we put another mass point here, M. Although we do not know the value of the mass here, it doesn't matter. But we do know the distance between M and M1 and the distance between M and M2. Okay. Now, so we know that both M1 and M2 are offering a force on M. So the force from M1, we call it F1, is pointing toward M1, and F2 from M2 is pointing to M2. So suppose direction to the right is positive. The direction to the right is positive. Okay. So according to the gravitational force equation, F1 gonna be equal to G M1M divided by their distance L1 squared, and similar for the F2 here. So the net force applying on M is this difference between these two forces. So we use F2 minus F1. Okay. Because F2 is positive direction, F1 is negative direction, so we use F2 minus F1, and we can get this equation. So we take M out, and we have Gm1 divided by L1 squared here. We have Gm2 divided by L2 squared here because we're using F2 minus F1. And we have times M. And according to Newton's second law, net force equal to mass times acceleration, right? Hence, the acceleration is equal to the net force divided by the M. So you can say that this M and M get canceled. Everything, all the left is Gm2 over L2 squared minus Gm1 over L1 squared, right? And we know the constant value G, we know the mass of M1 and M2, and we know the distance between these 2 points and these 2 points here. We'll plug in the number. Okay, the final answer that A is equal to negative 2.2 times 10 to the negative 9 meter per second squared. So this negative sign here is because we said to the right is a positive direction. Now we have negative sign here, which means the magnitude of A is still 2.2 times 10 to the negative 9 meter per second squared, but it points to the opposite direction of the positive direction, which is going to the left. So the direction of it is towards M1.